right. So I don't know if you had a chance to look at this. So R is going to be the centroid. Take your ruler if you can and just pick one of those medians. Measure the entire length of your median. On your little, yeah. Okay, measure the entire length of your median. And then notice, where does that centroid fall? You can either do it on a little paper triangle, or it looks like some of you are measuring it on your computer, which is great too. Let's say we're going to do for ease BQ if you're doing it on your computer. Six and a half. Do y'all get what, 6.5 inches? Can we do it in centimeters? Oh, it's 6 centimeters? 6.5 centimeters. Okay. Yeah, I know. It does depend. Okay. Would you please measure from B to R? And this may or may not work. Just, again, it depends. Okay. So we said that BQ was 6.5 centimeters, right? And BR is what? 4.5 centimeters. Let's see if this works. Would you please get your calculator out and tell me what 4.5 over 6.5 is? Yeah, this isn't working out. Okay, so this didn't work. It probably would have worked if you used the paper ones. So what you should know is that BR is 2/3 of BQ. Yeah. But again, you know, we're on the computer, we're measuring. It might have probably come out better on the little paper triangle. And RQ is RQ is 1/3 of segment BQ. So this is something that you're going to want to put into your spiral note cards. You're going to know what a centroid is, and you're going to want to show me that there is a 2/3 relationship to the whole length. Now here's where you're going to get mixed up. You're going to say, well, does 2/3 give me which length? Does it give me the bottom part or the top part? Well, look at it. The tip of the vertex to the centroid is a larger value, right? So that would be the 2/3 portion. Wouldn't that make sense? From the centroid to the midpoint of the side, that's the 1/3 relationship. So can you tell me how RQ and BR are related? If it's a 2/3 to 1/3 relationship, RQ equals half of BR. That's right. Okay, these are the relationships that you want to be able to remember. Okay? So in other words, if BR is 8, what's RQ? If the whole thing is 12, what's RQ? 4, because you're going to take 1/3 of the entire length. That leaves us to be 8. Yes? Yes, and it's for all of them. So I just did it for one. So this is a 2/3 relationship, 1/3. The important thing is that you're staying on the median. You can't go 2/3 of one median and then 1/3 of another median. You're staying on the median to find that 2/3, 1/3 relationship. Does that make sense? Y'all okay with that? RQ, well, Right. 2/3 is 1/3 plus 1/3, right? So that's going to be twice this value. Okay. Right. Okay, so here's an example. Here's my funky centroid. So when I give you the centroid, and I say that that's a vocabulary term, and I tell it to you in a problem, you need to right away recognize it was created by medians, okay? And remember, the other thing that we didn't say is that in a median, we didn't say that, wouldn't we agree that BL and LA are congruent? Right? Because we found the midpoint of that side. And then we would be able to say MB and BMC are congruent, yes? And these are congruent, yes? Is there a right angle anywhere in this problem? Is there a right angle at Q? Medians do not form right angles. Medians do not form right angles. What is not your friend in this problem? All right, you can't use it. But so I'd have to show that it's a perpendicular bisector. Yes, a perpendicular bisector is a median and an altitude. But if I just give you the median, you can't assume I have a perpendicular bisector. If I'm just giving an altitude, you can't assume that it's going to be a perpendicular bisector. You need to show me in this picture, or it needs to be shown that both the segments and a right angle are shown to be there, okay? Okay, so the centroid. RP is 8. RP is 8. AO is 12. That's the whole length. And PM, where's PM? PM is 4. Find RN, PO, AP, and SM. We'll pick which one do we want to work on first? You want to just do RN? All right. RN. Of that median, I gave you RP. So RN, the whole length, is what fraction? It's 2/3 of the whole thing is what? Right, RP. Write it down in words. Write it down with the letters, because you're going to do some manipulation. 2/3 of the entire length is equal to the part from the vertex to the centroid. So what part am I given? So 2/3 RN equals 8. How do I get rid of the 2/3? Multiply by the reciprocal. So RN is equal to 8 times 3/2, which is 12. You following my algebra? Set it up with your letters. Put in what you know. Solve for what you don't know. Abby? Sure, because what's PN? Because you know it's a 2-to-1 relationship, right? Absolutely. Okay, but this was a route that someone else went, so I just went with it. But yes, okay? So RN is 12. We found that one. Okay? PO. How do I find PO? So 1/3 of AO is PO. I need to see that equation. So 1/3 of 12 is PO, and so PO is 4. AP, what does that make AP? AP by default becomes 8, right? If the whole thing is 12 and the bottom part is 4, that leaves the upper part to be 8, right? And SM. So if this is 4, what's this? 8, and so we have this to be 12. Now this doesn't always work out nicely like this, okay? But SM is 12, right? Okay? All right, so we're going to do this with some algebra. we knew that we knew that this was 4. We were given that. So that meant this had to be 8 because it's 2 to 1 relationship. So to add them together, 8 and 4 is 12. Okay, let's do some algebra here. CG, where's my CG? Is 3x plus 7. CE is 6x. So the whole thing is 6x. I want to know what x is. What kind of an algebraic expression am I going to write? What am I going to say on here? Sarah? Perfect. That gives me 4x is equal to 3x plus 7. So x is equal to 7. Okay? What kind of relationship do I do with the fact that FG is y plus 8 and AF is 9y minus 6? What's that one going to be? The whole length is 9y minus 6. The bottom part is y plus 8. Athena? Nine y minus 6 equals y plus 8. And so this is 3y minus 2 is equal to y plus 8. 2y is equal to 10, so y is equal to 5. And the last one, I'm telling you, BG is 5z minus 1, and DG is 4z. Does that say minus 5? I had a blue line through mine. So what algebraic expression will I write here? What do you think? Sophia? Perfect. I don't like that too, and I know that when I pull it through, I'm going to have messy fractions, right? Move it to the other side. What am I really doing to the other side? So 5z minus 1 is equal to 8z minus 10. Yes? And so 3z is equal to 9, and so z is equal to 3. With the fractions? Yeah. I just hate fractions, so I try and get rid of them as much as I can, Abby. So we knew that there is a 2 to 1 relationship. So this value is twice this value gives me this one, or this one is half that one. Okay? Yes, Megan? You'd get this. You'd right away jump to my second step. I would have gone that route, right? But whatever way you see it. Okay, one last thing, and this is more about definitions. Orthocenter, we're not doing anything with this. Altitude, tell me what the definition of an altitude is. You need this in your assignment. Hey, Claire, where are your notes at, babe? Okay, you're not using your computer? Okay. So perpendicular, that implies right angle. Perpendicular from the vertex to opposite side. Yes? Is it an angle bisector? Is it a bisector of any kind? It doesn't divide your side up into 2 equal parts. It doesn't divide the angle. I'm trying to make sure you understand that because I'm going to give you a picture with lots of lines, and I'll say, show me the median, show me the angle bisector, show me the perpendicular bisector. You have to understand the vocabulary, and all of those lines will be drawn in one triangle. So if you aren't really clear, you won't know what we're talking about. Sarah? Huh? Okay, so here in an acute triangle, the orthocenters are all Inside. Yes. It's going to be in your note card along with the altitude if you don't already have it. Okay. A right triangle. You've got a right angle here. This segment coming down forms a right angle. This one comes across here, and this one comes down here and forms a right angle. So where is the orthocenter located now? Okay. So it's on the triangle. And at this point, it's at the right angle of the triangle, right? So what is it called when they all meet? Here. On the hypotenuse. That's the circumcenter. So you don't just tell me it falls on the triangle. You have to tell me it falls on the hypotenuse of the triangle. But this orthocenter falls at the right angle of the triangle. Okay? It's a little different. And then this one's a little difficult to see. But the obtuse triangle, if you're trying to create right angles, falls outside. And all I really want you to know is where does it fall. So inside an acute, on the right angle of a right, and outside on an obtuse triangle. I'm not going to have you showing me how to get it. I just want you to understand the vocabulary. Yeah. You can put one note card, right. You can if you want, but I would think it'd be better. You might see a little bit more if you do them individual, but you don't have to. Yes. Yes, Sarah? So think about it. Altitude is known as the height, right? If this is my obtuse triangle, don't we always draw the altitude down to the bottom and extend it out? That's what we're doing, but we're doing it to all three vertices. Does that help? Okay? So we've got a worksheet on Monday. We'll go over 2 sets of homework on Monday. We don't have time, all right? But we do have 7 minutes, so I do want you to try starting on your homework. Okay?